The absolute pressure below the surface of freshwater lake is 3.51 times 10 to the 5 pascals. So we should write this number down. Pascals tells us it's a pressure. We've also got another pressure over here, 1.01 times 10 to the 5 pascals. And we'll write those two down first. So there's our two pressures we've got. We know they're pressures because they've got the units pascals. The final part of the question also gives us another number here. The density of water is 1 times 10 to the 3. So you should always remember this number actually, just in case they don't give it. So we'll write down here the density of water, this funny Greek letter here for density, is 1 times 10 to the 3 or 1000. Okay. The next thing is to determine what the two pressures are actually, what are they? I mean, we've got two pressures, so we have to see what the difference is between them. It says here the surface of a freshwater lake is this much pressure. So below the surface is this much pressure, and atmospheric pressure is this much. So let's try and visualize what they're telling us. If we draw a lake, that's my lake here, it's saying some point below the surface of the lake, let's say here, at point X, the pressure here is 3.51 times 10 to the 5 pascals. Then it says atmospheric pressure. So if we imagine this is the sky or the atmosphere and space is above here, space, we're outer space. This is the atmosphere. All this gas, air, is a fluid, and so all of this contributes to a pressure. So we could say that the total pressure of this atmosphere is 1.01 times 10 to the 5 pascals. The question asks us, at what depth does this pressure occur? So it's asking us for this depth, how deep this is. So this height here. Okay, so we've got P, we've got density, we've got H. The formula we're going to use is for pressure underneath fluids. Density of the fluid times the height, or the depth, times G. And we're trying to find the height. G on Earth is 9.8, and the density is the density of the fluid, which they've told us, 1 times 10 to the power of 3. The pressure, we've been given 2, so this is the one we have to decide what to use. We're going to use this one or this one, or we're going to use some kind of combination. Well, if we use the 3.51, the total pressure at this point, that's including the whole pressure of the atmosphere. So if we use that, we'd be working out the height from there to the top of the atmosphere. If we use this pressure, the pressure of the atmosphere, we'd be working out the height from here to the top of the atmosphere. So we want the height from here to here. So we've got to take this pressure and take off this pressure. So this will actually be the pressure of the under the water minus the pressure of the atmosphere. Okay, so that will be 3.51 times 10 to the 5 minus 1.01 times 10 to the 5. And that's what we put in here. When you rearrange this to find H, it will work out to be H cross multiply equals P for pressure divided by density for water and gravity.